Welcome to Cinemeric Live, Application Technology Simply Explained, our video series which aims to present individual topics on application technology in short, simple, comprehensible films that don't take up too much of your time. Today's topic, turning technologies, longitudinal turning and plunge turning, differences and application using Cinemeric Operate. Our agenda for today, fundamentals of turning. What is turning anyway? What does it actually mean? It means longitudinal turning itself as an application, and then of course also plunge turning, grooving and separation, in other words cutting off the finished part. Turning with Cinemeric Operate as a follow-up point, with a sample workpiece on the machine itself, and then the summary, the comparison between longitudinal and plunge turning. Let's start with the fundamentals of turning. Turning is used for the production of rotationally symmetrical components. The workpiece rotates around its own axis, and the turning tool follows the programmed contour of the workpiece in the x-axis and in the z-axis. Categorization of turning technologies. In Cinemeric, these technologies are divided into stock removal by longitudinal turning, plunge turning and grooving. Now let's turn to longitudinal turning. During longitudinal turning, the turning tool moves parallel to the workpiece axis, as you can see here in the animation. Not only can the cylinder surface be machined, but the cylinder end can also be faced. Longitudinal turning can be used for both outer and inner diameters. Before machining inner diameters, a hole first has to be drilled. In contrast to longitudinal turning, with plunge turning, the stock is removed perpendicularly to the workpiece axis. By contrast, in longitudinal turning, this part can't be finished with this turning tool. You need a grooving tool which is also capable of producing these horizontal walls. The stock is removed by feeding in the vertical direction, immediately followed by a horizontal movement. Then vertical feeding again and repeated horizontal stock removal. This means there is practically no delay in rapid traverse. In other words, the stock removal is continuous. The plunge turning tool has 3 cutting edges for feeding in both the vertical and horizontal direction for stock removal. Another technology in this field is grooving. In this case, stock is removed vertically in relation to the workpiece axis. That is to say, the tool is fed, withdrawn, moved laterally, fed again, withdrawn again, moved again, and fed again. This process is mainly used for making grooves. At the end of the machining process, the workpiece is separated by the parting process. This means the machined workpiece has to be separated from the bar stock. This is done by means of the parting cycle. This is nothing other than a grooving process that extends beyond the center of the workpiece. Longer and thinner grooving tools are used to minimize the cutting pressure and keep material loss low. To afford better control of the rotating separated workpiece in this functionality, Cinemeric Operate provides the option of reducing the speed shortly before the actual parting process. Now we're going to produce this handle to give a practical demonstration of the technologies we've discussed. Before we begin, please note the following. This handle consists of flowing contours of various radii with smooth transitions and of vertical edges and walls. This part cannot be made by plunging and grooving alone. The straight cutting edges of the grooving tool cannot complete the entire radius. Longitudinal turning gives us the radii, but not this vertical edge. The shape of the longitudinal turning tool simply doesn't allow it. The only way of doing this is a combination of longitudinal and plunge turning. On the one hand, this allows us to achieve all of the radii, and on the other, we can make the vertical 90-degree edges.
90-Grad-Kanten zu fertigen.
We need a contour to make this handle. This was generated by the contour calculator in Operate and serves as the basis for the technologies needed to produce this handle. In this case, for contour turning, we have all the applications we need in the vertical soft key toolbar for producing this contour. In other words, longitudinal turning, grooving, plunge turning and residual material machining. Here, for example, for the plunge turning, you can very easily enter all the relevant technological data on the screen and check the entire manufacturing process in advance in the simulation with the animated elements. As you've just seen in practice, this component cannot be produced with either longitudinal turning or plunge turning alone. A combination of both technologies is needed. To sum up, we can say that plunge turning is used for forms with deep grooves, areas with steep walls, and longitudinal turning is used for flowing transitions for radii. Thanks for watching, and see you next time.